Hello, everybody, and welcome to lesson 1.7 in your textbook. It is on page 48, and this lesson is on proving angles that are congruent. Remember, the word congruent means equal in measure, and this is the symbol for it. And we're not going to prove, but we're going to apply theorems, which is a theorem is a proven statement in math about angles. First of all, angles are two rays that meet at a common point, which is called the vertex, and it's measured in degrees. So the degrees tell you how big the angle is, and it's a little circle that's usually above the number or the algebraic expression. And certain angles add up to a special sum, like 180 degrees is a straight line. So a straight line has 180 degrees, and a full circle has, if you go from here and you go all the way around, that's 360 degrees. And a 90-degree angle is called a right angle. And the symbol we use is this little corner, and that's 90 degrees or right. Remember, the symbol for angle is this little symbol here. It's not the less than symbol. It's got a horizontal bottom, not a flat bottom, not a less than symbol. So 90-degree angles, 180 degree, 360 doesn't come in this lesson, but I wanted you to know that. And so the one down on the bottom, they're talking about vertical angles. So the vertical angle is important. It comes up a lot in this lesson. The vertical angles are the ones that are across from each other if you have two intersecting lines. So 1 and 3 are vertical angles and they're congruent. See that symbol? That means they have equal measure, okay? 2 and 4 are also vertical angles. Notice they're across from each other. These little bows, by the way, indicate angle size, and you start and end where the angle starts and ends. 2 and 4 are vertical angles and they are congruent. Angle 2 congruent to angle 4, vertical angles theorem. Okay. All right. And what do you think the sum of all four of these is? 360, because it's going to complete a full circle. Now this right here, this straight line, so angle 1 and 2 are not equal. Their sum is 180 because they form a straight line. So I'm going to draw that up here. So if you have two angles that form a straight line, do you see the straight line down here? This is one angle. This is the other angle. Sometimes I even use little arrows here. These are called supplementary. There's a word for it, linear pair. A linear pair forms a straight line, two angles that form a straight line. And sum is always 180. The sum of the two is always equal to 180 degrees. By the way, the word for that is called supplementary. I'm going to throw that into supplementary angles. Supplementary angles, always the sum is 180, okay? So let me come up with some numbers that would work out. I'm just making up an example. Let's say this angle is 60 degrees. Then this one would be 120 degrees because 120 plus 60, the sum is 180. So any of these two numbers that work out to where you add them and the sum is 180, they will form a linear pair and the sum is supplementary. Another thing I wanted to talk about is the size. This angle here is called obtuse because it's bigger than 90 degrees, and this is acute. Obtuse angle, acute angle, yeah? Obtuse is bigger than 90 degrees, so they're kind of wider. Acute, less than 90 degrees, and they're narrower. All right, let's see, what else do we need to know on this page? Okay, this right here, essential understanding. I'm just reading it. You can use given information, definitions, properties, which are rules in math and geometry, postulates, and previously proven theorems as reasons in a proof. We're not doing too many proofs. We're only doing like 2, I believe, but I want to get you an idea what a proof looks like. What's the difference between postulate and theorem? A postulate is understood to be true without proof, and a theorem has been proven to be true. Like a postulate would be through any 2 points, you can only draw one specific line. There's no other way to draw a line through these 2 points. So that would be a postulate. There's no proof needed. That's understood to be true. And there's a question on your homework. I'm going to ask you about that. What's the difference between a theorem and a postulate? So on the next page, we are skipping, wait, where are we? Wait. Yeah, we're on this page. So we're on page 49 on the top. This is a proof that I'm going to skip, but we're going to look at problem 1 using the vertical angles theorem. Remember, vertical angles are equal. And so you're looking at this drawing here and you see 2 vertical angles across from each other, but they don't have a number in it. They don't have a measure. They have these algebraic expressions. See the little degree sign up here and up here? This just means it's 3x degrees and it's 2x plus 40 degrees. And your job is to find x. So whenever it's asking you to find a value of x, you have to set up an equation and solve. So let's think over here. I always want to look at these. How can you check that your answer is correct? Plug it back into the equation. Or you can plug it in here and I'll call that into the expressions. Or you can plug it in to the equation. One side should equal the other side when you work it out. All right, so remember, vertical angles are equal. That's my clue. Vertical angles are equal or congruent. So the equal sign tells me that this angle, which all I know it's 3x, is equal to this angle, and all I know is that that angle is 2x plus 40. And now you have an equation. This is called an equation you have to solve, and that's another task you might have a hard time with. So we got x's on both sides. So I'm going to move my x's to one side. I'll subtract 1 here and here, line them up. 3x minus 2x is simply x, or 1x. This is gone, and that's the 40. So x is 40. That was easy, right? We found x, 40. Now that's the end of the question, but I want to go a step further and I want to also find each angle measure. Okay, so if you need to find the angle measure, you're going to plug in for x 40 because x is 40, okay? By the way, to check if it's right, we can use our equation. I'm going to do that down here. 3 times 40, because x is 40. 3 times 40 has to equal 2 times 40 plus 40. Well, there's a lot of 40s here. So let's check if one side, 3 times 4 is 12 and attaches 0. 2 times 4 is 8 and attaches 0 plus 40. That's true. 120 is 80 plus 40. Check it out. So we got it. We found the right number. So you always can check to plug it back in. But I want to find the angle measure. 3 times 40, that one is 120 degrees. And 2 times 40 plus 40 is also 120 degrees. Because 2 times 40 is 80 plus 40 is 120. So that would be each angle measures 120 degrees, which makes sense. It's obtuse. The angle is wider than 90 degrees. And you could even find these two. I want to see how many of you can figure out these two here. I'm not going to give you that answer, but if you're really interested, what's this measure and what's this measure? These two numbers have to be equal. They're vertical angles as well. So if you are interested in telling me this is 120, this is 120, what are these two? But there, remember, the sum has to be 360 and they're equal. That's the clue. You can figure that out. And then I want to show you number 1 here. Find the value of each variable. So we're going to look at what variable are they talking about. We got an x and a y. So I will look at the vertical angles first. This one and this one, these are called vertical angles. And remember, they're equal. Are equal or congruent. You can call it congruent, but we're setting up an equation, so we'll call it equal. So we got one angle equal to the other angle. And that's your equation. And now you solve it. And when you solve it, you just want to isolate your x. So you got two sides, left side, right side. Whatever you do to one side, you've got to do to the other side. I'm dividing by 2 both sides. Division property of equality. So we have left x is 38. So we got x is 38. Now we got to find y because it says each variable. Yeah. So I'm going to change my view here and I'm going to look at this linear pair. Look at this line, that's a straight line. So these two angles here, they're not equal. They form a linear pair. And what did we say about linear pair? The sum is 180. Different than equal. We got vertical angles are equal, but linear pairs add up to 180. So we would say 2x plus y is equal to 180. This angle plus this angle add up to a straight line. Okay, we know x, 38. Look at that. We're going to plug that in here. It says 2 times x, so it's 2 times 38 plus y is equal to 180. 2 times 38 is 76 plus y is 180. Subtract 76 and y is 180 minus 76 for 104. Yep. So y is 104. So we got 104 degrees. And this one is 2 times x, which is 38, which is 76. And this one is 76. And then this one would be also 104 because these two are opposite vertical. And the sum has to be 360, a full circle. The degree sign has to be a little bit higher and smaller, otherwise you'll think it's a 0. It's not a 0, it's just means degrees. So 76 plus 1 plus 76 plus 1 4 equals 360, a full circle. All right, so did we answer find the value of each variable? Yes, we got x, we got y. And now the next question says, find the measure of the labeled angles. So we already have them, 104 and 76 and another 76 and another 104. Okay. All right, guys, this is what you need to know for this lesson. You need to know vertical angles, supplementary angles, which are linear pairs. You need to know how to set up the equation for vertical angles and how to set up the equation for supplementary angles, linear pairs. And so there's one more angle that's called complementary. We'll come up to that in a second. Okay, I'm going to look at the next page. I think this is done. We're skipping this one. We're going straight to page 51. Page 51. To the top, we're doing this proof, which are easier because they're just giving you the outline. This is called a 2-column proof. The 2-column proof has on one side the statement that you make and then the reasons. Okay, and let's look at the question. Complete the following proof by filling in the blanks. The given information is what you have to work with. And this photo here, this little diagram, you look at that. Angle 1 congruent to angle 3. I always mark it. 1 and 3 are the same measure. We're supposed to prove that angle 6 is congruent to angle 4. We're supposed to prove these are congruent. That's the last statement. That's always at the end. The given is always the first statement. Yeah, the given is always the first. All right, now let's look. Angle 1 and 3 are congruent. That's the given. Then it says angle 3 is congruent to angle 6. I'm going to mark my picture different. 3 and 6. Why is that? They are, what do you call these? Starts with a V. 3 and 6 are vertical angles. Vertical angles are congruent or equal in measure. Yeah, 3 and 6. Okay, then let's look. What's the next? Oh, then they're talking about transitive property. Okay, look here. This is where that comes from. Look what it says here. Angle 1 is congruent to angle 3, and angle 3 is congruent to angle 6. Therefore, you can go straight from the first to the last and skip the middle. Therefore, angle 1 has to be congruent. Angle 1 has to be also congruent to angle 6. It's called transitive property of congruence. You skip the middle. Okay. All right, so we got that. And now what does it say? 1 and 4 are congruent. Why is that? Oh, look at that. 1 and 4 are also vertical angles. They're the ones that are opposite when two lines cross. Vertical angles are congruent, right? Okay, we're almost done with our proof. I bet it's another transitive property. Look here. Yep. Well, or no, maybe substitution. Angle 1 is congruent to angle 4 and 6 is congruent to angle 4. Notice these two angles are equal. Of course, they're the same angle, right? They're equal to itself. Therefore, these two must be equal as well. Yeah, so that's called substitution, I believe. Substitution property of congruence. I'm leaving that off, right? If something is equal, you can substitute it. And then the proof is done. Then we have shown with reasons that are legitimate. Remember, the reasons have to be definitions, theorems, postulates, all that, what I went over on the first page counts. So you have to kind of go into what you already learned and apply it. And next, I want to just show you, this is called a 2-column proof. This is now a paragraph proof. A paragraph proof is just written out. So I'm just walking you through this one. Given in the problem, angle 1 congruent to angle 4. So these two angles are congruent, same measure. And we're supposed to prove that 2 and 3 are congruent. So here's how a paragraph proof looks like. Angle 1 is congruent to angle 4 is given. Angle 4 is congruent to angle 2 because vertical angles are congruent. 4 and 2 are vertical angles. Notice that, right? Across from each other. By the transitive property of congruence, angle 1 is congruent to angle 2 because 4 and 4 is the middle. You can go straight from first to last, right? And angle 1 is congruent to angle 3, also vertical angles. So 1 and 1 are the same, therefore 2 and 3. Oh, they're using transitive property. That's probably what I should have written here, transitive, because it's the same. I'm going to make it a little better then, or I'll say or transitive. Transitive property. They use it, they say transitive here, so I will use the same up there. So nothing big, it's just that you kind of like a story unfolds with the paragraph proof. All right, on the bottom of this page 51, there is a theorem, congruent supplement. Remember supplement? Remember what I said, supplementary angle or sum of supplementary angles is always equal to 180 degrees. Supplementary angles. Yeah, so let's look. If two angles are supplements, which means their sum is 180 of the same angle, then the two angles are congruent. It kind of uses transitivity here. Let's say if angle 1 and 3, these two are supplements. So that means the angle 1 and 3, their sum is 180. So I'm going to assign some numbers. I'm just going to say, how about if this one is 60 degrees and this one is 120 degrees, right? The sum is 180. This one is acute, this one is obtuse. And I just picked numbers. It can be any combination of numbers that add up to 180. Okay, then 2 and 3 are supplements. If these two are supplements, then this one has to be 60 degrees because these two also have to add to 180. Then here's the conclusion, 1 and 2 must be equal. 1 and 2 must be equal. That makes sense to me. I hope to you also. So that's the congruent supplement theorem. And if I'm going too fast here, stop for a minute, make sense of it, read it over one more time. That always helps, okay? And then on this page, We're skipping this page and we're going straight to page 53. We're almost done. On top of 53, we got 3 more of these, okay? It's about the same kind of concept. This time it says complement. Now remember complement, I mentioned it, sum is 90 degrees. So sum of complementary angles, if 2 angles are complementary, their sum is 90 degrees. So they always make a right angle, yeah? So the 2 words are complementary and supplementary that you have to know. So here's the theorem. If 2 angles are complements, these 2, 1 and 2 are complements. So I'm making up a number. So if you add the sum of these 2 angles, they will add up to 90. So I'll make this one, how about this one, 40? And then this one would be 50, right? So if 1 and 2 are complements and 3 and 2 are complements, 3 and 2 are complements, then 1 and 3 must be equal, congruent. So notice they are, right? If any number I choose, it'll always work out that these 2 must be equal if these 2 are complement and these 2 are complement. Okay? And then we have right angles. Remember the symbol for a right angle is this little corner, yeah? It says all right angles are congruent, right? That makes sense because all right angles are 90 degrees. So 1 and 2 are right angles, then 1 must be congruent to 2. Makes sense, okay? And if 2 angles are congruent and supplementary, then each must be a right angle. So these 2 angles are congruent and they're supplementary. They're supplements of each other. So their sum has to be 180. Well, if they're the same and their sum is 180, the only number that works is 90 degrees. Because 90 plus 90 is the same angle. They're congruent, it says here, and their sum is 180. So then measure angle 1 equals measure angle 2, and they're both 90. Okay. And now we're going to start on your homework. This is the part where you have to try your very, very best. When I say very, very best, I don't mean close the book at this point. It means you got to try each question to the best of your ability. Okay, homework is the practice. What is the measure of angle 1, angle 2, and angle 3? So you're looking for, the clue here is this little, this is 90 degrees, right? So look at, you can already see what angle 1 is. Okay, so I'm going to let you think about that one. I would love it if you guys can come up with an answer on that. Think about it. Use the lesson. Go to the next page. So we're on page 54. You're going to do number 6. Now make sure you work out the equation. Don't guess. It means show your work. Some questions you have to show work. These 2 angles are vertical angles. And they're equal. So there's your clue about your equation. Okay, look at back in the examples. Make sure you work it out. Number 7 is one of those theorems we talked about, the supplementary theorems we just went over. Number 8 is an error. See if you can find the error. Again, any question you have not been able to figure out, we will go over it in class. You need to say, I could not understand number 8. Can you show it to us? That's the way to do it, okay? Now, number 9, we talked about what's the difference between a theorem and a postulate, and I talked about that in my lesson. And then we're going to look at this street map here. The clue here is, so the clue is right there. This angle here is 35 degrees, and this is a right angle. So these are the clues. You have to focus. What is the measure of the angle formed by Park Street and 1/16th? So you're looking for this angle right here. This is what you're looking for. So there you go. And then now you're going to solve an equation, this and this. These two angles are vertical again. So your job is to solve the equation. If you don't have room here, you can do it right here. There's room right here. Okay, so number 12, and this is a miniature golf. This is interesting. So this will, you will have to use this straight line right here, the ground. So you got 1, 2, 3, 4 angles, and the sum of all 4 angles is equal to 180 because it's a straight line. Remember, they form a straight line, the ground. So that's your clue. You got to find X and Y. You got to find these two angles. And they're equal, by the way. So that's that page. And I think that's it for you in this lesson. And I also want to tell you what perpendicular means, the word perpendicular. The symbol is this, so you can kind of already guess, 2 lines that meet at a 90 degrees. So good luck on this. Make sure you do your homework.